Hey guys, so it's been a while since my last tutorial, so I figured it was about time I did another one. And in this one, this is going to be a comparatively short one, and we're just going to take a look at how we can sort of animate one piece of geometry into another, sort of unrolling or re-rolling the surface, if you will. So this is basically what we're going to be doing. You can see we have the option to take a plane and translate it into another object. Now this relies on one very important characteristic of a surface, that it is an untrimmed single surface. And that way it also means that we can basically translate any single surface into any other surface. And just for demonstration purposes, I will plug this in here, and we can see that I can now transform this torus shape into a sphere. Alright, so let's get started. So the first thing we're going to do is, firstly we're going to drop down a plane surface in fact. So this is going to be our one item of geometry that we're translating in between. And I'm just going to set some parameters, so give it a maximum value of 100 for the X, and actually I'll make a separate slider for the Y. And what I'll also want to do is I want them to be from a negative to positive value so that they form right around the origin. So I'll do this for my X, make a copy of that, do the same for my Y, and there we go, we've got this completely centered plane. And now the other thing we're going to do is we're going to construct our torus, or semi-torus in fact. And the way we're going to do that is with a series of points. So I'm going to drop down a couple of sliders as well. You know what, we'll give them a maximum value of 100. So I'm going to start by defining a Y point. It's going to be somewhere out here. And then I'm going to make a copy of that, and I'm going to give it a Z value as well. And then we'll make another copy of that. We'll remove our Y value, make another copy, and we're gonna make our Y value negative and add that in. And then we're gonna do it one more time, and we're gonna remove our Z. And actually, one more thing that I might want to do is add in a sort of Z offset. The way I'm gonna do this is just like this. And then I'm going to add this number into the Z values into the construct point nodes with no Z value. So this is basically like an offset height, and this is the actual height of our geometry. And then I'm going to quickly line all of these up, and then I'm going to put these into a merge node. So I'm going to go 1, 2, 3, 4, 5. We can remove the sixth one, and then we're going to create a polyline through all of these. And then I'm going to put down a divide curve node and a slider with my maximum value of 24. And then I'm going to put a NURBS curve through these. Oops, wrong kind of NURBS curve. This one here. And we're going to get basically a nice controllable shape. Okay, cool. So now I can preview all of these off, and this is basically just a nice resolution slider. Can do whatever we want with it. Okay, cool. So now these are going to form my two base pieces of geometry. Actually, one more thing I need to do is I need to do a revolution. So I'm going to revolve this NURBS curve around the y-axis. So I'm going to create a line SDL for start, direction, and length, because this is what we need for our axis, and my direction is going to be defined by a y vector, and my start point is just going to be a construct point node. Okay, there we go. Now I'm not quite liking the shape of that at the moment. I'll give this a bit more of a gap in the middle, and narrow this up a little, and take this height down. And you know what, I might kind of like it like that. Okay, so now what we're going to do, now that we've revolved that surface, is we're going to put down a divide surface component. And I'm going to do the same for my plane as well. And I'm just going to put down some parameters for my x and y, for my u and v, sorry. Okay. So the first thing I want to check is that I'm getting divisions in the correct direction. And you can see as I'm adding resolution into the U count, it is increasing along this axis on my semi-torus and along this axis on my plane, which is precisely what we want. If for whatever reason it was the wrong way around, let's say we had our XY plane and then we rotated that plane by 0.5 times pi, which is 90 degrees, and then plug that in there, you'd see that we've sort of got a mismatch of attributes. So I just have to simply flip this around the other way, and then I'd also need to flip my data structure, because you can see those don't quite match up, so just flip this matrix coming out of here, and then we'd have matching attributes. Yeah, cool. But we do not need to do that. So what I will do actually is we might keep this plane rotation here, just because it could be an interesting component to work with. So I'm just going to throw down a pi modifier, plug that into my angle, reset that, and realign these. Okay, cool. So now what we want to do is, okay, so for starters, we could just create a straight vector 2 point between A and B, and preview these off. Okay, this is going to be the absolute simplest way that we could do it. And then use a multiplier, and we're going to multiply this vector by some amount, and then we're going to add it to this point here. And then we're going to reconstruct the surface. And the way we're going to do that is a surface from points. So I'm going to put my point collection over here. I'm going to flatten this input as well, and my U count is going to be this over here. Oops. Okay, we're going to go U plus 1, and we're just going to change this to U, get rid of my Y, and plug that in. Okay. So now as we animate through this slider, you're going to see that we're going to get some sort of representation of a transformation from that torus to the plane. But we can do a little bit better than that. And also, the first issue I'm noticing is that the plane, or the geometry, is crossing over in a way that I'm not too fond of. I don't want my geometry to move right through itself. So what we're going to do is we're going to grab a list item, and we're going to flatten that input, and we're going to drop down a slider with a maximum value of 50. and then I'm going to make a copy of that list item. And what this is basically going to show us is how the geometry, or whether our geometries are aligned properly. So you can see automatically, or straight off the bat, that it's going in the wrong, firstly the wrong direction this way, and secondly the wrong direction around the axis. So what we need to do is we need to correct this. The way we're going to do this is with a path mapper. So I'm going to put my path mapper in. So we know that we need to flip both axes. So I'm just going to simplify the data coming in here. I'm going to create my null mapping, and we're going to use some of these items down here to fix that. What we're going to do is we're going to do path count minus a minus 1. This is basically going to reverse the path, or the path order. So when I plug this into B now, you should see that, okay, we've corrected one direction of the motion, but it still crosses over through the, through the Y, in the Y direction. So we also need to flip the index count. The way we're going to do that is pretty much the exact same way. We're going to go item count minus I minus 1. And so now, as we chug through this slider, it's going to go from the torus to the plane. Now, I mean, this is all well and good, but or this is certainly one way you could do it, but I'm going to make it a teeny bit more interesting. And the way I'm going to do that is I'm going to use a subsurface isotrim, sorry, and I'm going to construct a square domain. I'm going to reparameterize the surface as well. And so what I want to do is I want the surface to slowly sort of cut away. So you can see, okay, I'll just turn off this revolution. Okay, so what I want to do is I want the surface to sort of split away from this seam over here. And the way we're going to do that is with, let me see, I think I want to create an expression which is going to be 1 minus x. Okay, and you can see that basically does the job, except that once we get to 0.5, that's the extent of what we need. So what I'm going to do is I'm just going to, okay, so that was just a check. What I'm going to do is I'm going to put down a range. I'm going to put down a number of values for that range, give it up to 24, and I'm going to multiply this output by 0.5. This is going to go in here and in here, and that'll give me all my ranges between, well, a full surface and a half surface. Okay, and so now what we can do, in fact actually I might just do this to 0.25. Okay, so now we can divide this surface again. And now what I'm going to want to do is, instead of, okay, now we need to rethink about our data structure. So what I'm going to do is, with this, after this path mapper, I'm going to shift the paths. Actually, no, wait, we probably can't do that because, yeah, we've only got 2 dimensions of data, so there's no point in path shifting because all we need to do is flatten. Okay, but we will need to do it over here. So what we need to get is let's see, we just need to shift these paths, and that'll give us 140 items here and 140 items here, so 140 items per each list. Quickly lock the solver and replace these two values. And let's see. So now what we want to do is we want another range. Oh, actually we don't need another range, we can use the same one. And we can graft the input here. And then we can use that over here. Oh, has that done the right thing? There's 25 items here, 25 here. Actually, what we might want to do is, that should be right. Okay, so instead of creating a whole bunch of surfaces, we are going to hold on, something's not quite right here. So we have, let's see, 25 vectors here, or 25 numbers here, 25 values here, and yes, of course, I just need to plug my path shift in here so that we've got a proper match of attributes. So we've got 25 paths, and I can now flip that matrix. And then we can create a NURBS curve through it. And this will basically give us the animation path. So what I'm going to do is I'm just going to use an evaluate curve. And I'm going to plug that number in there, flatten this output here, and this should give us a surface now. So I'm just going to turn off all this extra geometry, and if we turn this surface on, we can see, also just turn surface interpolation on so that we're getting better constructed geometry. As I animate through this, okay, I also need to reparameterize the curve. We're going to go from a nice torus knot to our plane. It's going to have some really nice animation on it because we're half unrolling the surface and then we're also half targeting the plane. Now we could take this another step further, because what we have here is we just have sort of linear interpolation here because we've just taken a range value. And what we could do is we could insert a graph mapper in between these and use our Bezier interpolation and then plug that into here. And so at the moment we're going to have just a straight linear interpolation method, but if we were to change this up a little bit, you could see we'd get really quick interpolation in the middle and then real slow interpolation right at the ends. And we could take this another step further. We could deconstruct this vector, and then we could create 3 separate graph mappers, and we could multiply our X result, our Y result, and our Z result separately. And then we'll construct point again on the other side, X, Y, and Z, and then that means we're completely bypassing this node here, and that will allow us to change the shape of the interpolation in any which direction we want. So as we're interpolating through this, we can get some real strange shapes just by creating a different interpolation method. And one more way that we could do this that would be kind of interesting is we could use, for instance, a trig function. In fact, we're going to use cosine because cosine starts and we can get it. Oh, it will start at the lowest point, and we can get it to finish at the highest point a bit easier. What I'm going to do is I'm going to plug in this range. Actually, I'm going to plug in the grafted range because that's what we've been using. And we're going to go, let's see, negative cosine of y times pi. Actually, for starters, we'll just go pi times x. And so that's going to give us value between -1 and 1. So we want to go -0.5 times cosine pi times x plus 0.5, and this should now make it between 1 and 0, which is what we want for our slider. And so if we plug this into our z interpolation, what we could also do is we could throw in a y times here, and this would allow us to basically oscillate the motion between 0 and 1 several times. If we were to set this to, it needs to be an odd number, we could set it to 11 odd numbers, and then plug it in. And you'll see we're getting this oscillation in between the sort of initial and final result. And if we just preview off our NURBS curves, you can see the surface will go from, well, basically from the initial torus knot to almost flat, then back out to somewhere in between, then almost flat again, then pop out again, and back to completely flat. And we could basically control the number of times this happens. Of course, in order to do that, we might need to increase our number of steps as well. But it's creating this really nice kind of bounce effect. I'm just going to turn that back down to 3. Okay, now final thing we're going to do is we are going to look at how we can bring in another piece of geometry into this. And so what I'm going to do is I'm going to create a sphere. And I'm going to change this sphere to have a radius of maybe 100. Oh, around there somewhere will do for me. Okay, and so we could start off the bat by just plugging this into our subsurface, but actually what we should firstly check is that our divisions are working the right way. So if I have my list item for my reference plane, and I have my list item for my target geometry. If I turn these on and just highlight them, let me see, let me turn off these pieces of geometry here and just highlight these values. Okay, so we're getting something quite weird for starters. What I might do is I might just take this plane rotation that we created over here, and instead of plugging it in there, plug it into my sphere, set to 0.5, and let's see how the the points match up at the moment. Okay, that is a bit better. Let's try it out. So we'll plug our sphere into the subsurface over here, turn it off, and then if we go back to our animation slider, okay, so we're getting quite a weird result off the bat. Let's see where the problem is. For starters, we've got that cosine value set to 3. I might just go back to my initial slider and let's see what happens. In fact, I might just go back to this slider over here. So we can see the surface is turning around on itself. So what I might try and do, there's a couple of things we could try. For starters, I might make this value negative. And there we go. This seems to have addressed the issue. So basically I just rotated my sphere around the other way so that the interpolation method, or so that the points sort of were just better matching each other. And you can see that works a lot better off the bat. A really cool thing about this technique as well is that the curves, you can see the animation curves, and they do actually produce some pretty cool results. I've rendered out a couple of these curves just because they gave me some really nice results. And sort of the last thing we could do is we could basically take this sphere and we could convert the revolution surface over here from a torus to a sphere just by plugging this in here. You can see we've got this method for turning a torus now into a sphere. And basically, you can turn any kind of single surface into any other kind with this method. You just need to align your UV points and mess around with the animation parameters a little, and yeah, there's a lot you can do with it. Have fun with this definition.